Alright, so this is the section on number patterns. We will be looking at number patterns from grade 9 and also the new content for grade 10. So first up, let's go to what we know from the past. You should know that T1 represents the first term in a number pattern. T2 represents the second term in your number pattern or sequence, and T3 represents the third term. Tn is called the general term because we can find the value of different positions in that sequence. So if you want to know what is the number that is in position 10, you would have to substitute 10 where you see n. Okay, what is the value of the term that is in position 10 in your sequence? So in grade 10 you will only focus on linear patterns, and in future grades you will look at more complex number patterns. So starting out, we have example 1, and you might be wondering why there is DNA on the right hand side of my screen, and that is there because I want to show you a quick formula to get the general term for any linear sequence. So firstly, let's do it in another color. We can say that Tn is equal to Dn plus A. That's where the DNA comes in. So if you want your general sequence, you just need to know your constant difference, right? Which we get when we say term 2 minus term 1 or term 3 minus term 2. We just figure out what was added or subtracted from one term to get to the following term. The A, like the first letter of the alphabet, is our first term, but in actual fact it's term 0. It's term 0, and so we want to find T0, the term or the value before the first term. So we kind of go backwards to figure out what is term 0. Alright, so let's start. The first question here is to determine the general term for the above mentioned sequence. So we start off by rewriting the sequence. We got 3, 7, 11, 15, and 19. Okay, we can see from here that we are adding 4 to each term, so our constant difference, this value over here, is positive 4. Okay, but now we need to figure out what is our term 0. So our term 0 will be over here, right? And so as opposed to adding 4, for us to get the term before 3, we need to subtract 4, and 3 minus 4 is minus 1. Okay, and it works out because when we say minus 1 plus the 4, we get our first term, which is 3. And so the final sequence here for Tn is that Tn is equal to our yellow difference, our constant difference of 4, right, minus 1, which is the A that I was speaking about in DNA. And so the general term for this sequence is 4n minus 1. The second question is to determine the 20th term. So what is the number that is in position 20 for this number pattern? And so we now have to say that Tn is equal to 4n minus 1, and then we substitute 20 in position n, and this works out to be 79. So the 20th term in the sequence has a value of 79. And finally, the last question, which term in this pattern equals to 399? So we are given the value that is in a certain position, and so that value will be substituted as Tn. Okay, and so once more we start and we say that Tn is equal to 4n minus 1, right? The value is 399, right? Which is equal to 4n minus 1. And now it's just a matter of simple solving, right? So we add 1 on both sides to end up with 400 equal to 4n. And so therefore, finally, n is equal to 100. That means that the 100th term in the sequence will have the value of 399. Up next, we have